When we talk about dimensions, we are looking at a single dimension, which is just a line. Okay, this is one dimension. And then when we actually have an area or a plane that is two dimensions, then we can actually have stretched out so that if we were to stretch a square out into the z-axis, now we have a cube, which is three dimensions. And of course, there could also be a fourth dimension and fifth dimension and so on. And it could go up to as high as 11th dimension and beyond in mathematics. I am not going to even try to even explain that. But as far as the fourth dimension, you could see the shadow of the fourth dimension as a three-dimensional tesseract. So if you want to take a look at that later on, I could give you the links to that. However, let's take a look at a cube here and consider a cube with sides 2 meters each. So cube is basically a square that is stretched out into a three-dimensional object. So 2 meters by 2 meters by 2 meters. Okay, so the length of height, width, and depth represent 2 meters each. Okay, so each side has dimension of length, and the unit for each side is measured in meters. Okay, so dimension-wise, it's length, units, and meters. Now, if we were to take a look at the area of one side, okay, so here, if we were to look at the area of one side, okay, the area is a two-dimensional plane with 2 meters by 2 meters, okay, and dimension for area is length squared. And the units for the area, right? So area, of course, is equal to length times height or width, same thing. So the meters times meters is equal to meters squared, okay? So that will be the units for area, meters squared. Now the volume is going to be the three-dimensional object here as a volume, and volume is equal to length times width times height, right? So dimension for the volume will be length cubed, and the units will be represented as meters cubed, because here the length will be measured in meters, the width will be measured in meters, and height will also be measured in meters. Therefore, meters cubed would be the units. All right. So let's consider a speed of a car. Now, speed is a representation of how fast things are moving. So to define speed, it is a rate of distance covered. So if you were to think about the word rate, people don't realize what that word rate means. So I always like to make an example. For example, if I ask a student, say, "Oh, does anyone babysit?" And I'm sure I always get at least one student raise hand saying, "Oh, I babysit." And I ask, "How much do you charge?" And the student may say, "Oh, I charge $10." Wow, that's cheap. Can you come over to my house and babysit my three boys for a whole weekend and I'll give you $10? Of course, they'll laugh at me. It's like, "Oh, Mr. Kim, are you kidding me? I charge $10 per hour." Now, this babysitter gave me his or her rate, right? The rate of $10 per hour. So the rate means unit per unit of time. So there has to be time factor involved in the word rate. So rate of distance covered means how much distance per unit of time is what that rate means. So speed is exactly that, okay? It is length divided by time. So that is pretty much the dimension of our speed, right? Length divided by time. And length has unit of, in this case, it is miles. And time is in hours. So if we were to look for the speed in this case, which is length divided by time, this triple equal sign means truly equals to. It's a definition, mathematical definition. So since the length is 10 miles, time is 2 hours, our speed comes out to 5 miles per hour as our speed. Okay? All right. Let's consider a cylinder with length of 5 meters and radius of 1 meter. All right, so we all know what cylinder looks like. So cylinder here, let's say, is a circle with tube and circle at the bottom. So what is a surface area? Well, the surface area, if you were to look at this, okay, well, first we have radius is equal to 1 meter, and length is equal to 5 meters. The surface area of cylinder, if you were to think about a can has a top lid and it also has a bottom lid and the cylindrical tube as well. So if we were to actually open this can up, what happens? Well, what we would see is we would see the top lid, right? Top lid right here. And then if we open this tubular structure up and flatten it out, we would have that. And then we would have the bottom lid as so. Everybody okay with that? So if you were to take a look at the top lid, this here has a radius of 1. And the bottom lid also has a radius of 1 meter. 1 meter. And the length of the cylindrical tube will have 5 meters worth of value. But what about this right here? Can anybody tell me what that length is? Come on, somebody tell me. Please. What would this be? Winner, winner, chicken dinner. That is absolutely correct, Will. Nice job. All right. This would be the circumference right here. This is the circumference of a circle, right? Which is equal to 2 pi r. All right. So let's think about the areas that are involved. So the area for the top part, top lid is, right, 2 pi r. And since we know r is equal to only 1 meter, so we have 2 pi times 1, and that, I'm sorry, pi r squared, pi r squared. So that is equal to pi times 1 squared, and you get pi meters squared. And for the bottom, here you get area again is equal to, same as the top, this is symmetrical, so pi meters squared. And at the bottom, here we have area for the rectangular part is equal to length times the circumference, right? So that is 5 meters times 2 pi times 1 meter. So we have 10 pi meters squared. So now we can say, oh, what is the total area? So total area is equal to, okay, we have area of the rectangular part plus the area of the circle part at the top plus the area of the bottom lid, right? Therefore, the total area is equal to 10 pi plus pi plus pi, and that comes out to 12 pi meters squared as my total area. All right. I will stop the recording here.